Hello to everyone. You're welcome to our second lesson on our differential equation course. Today we are going to look at our linearity conditions. We have three linearity conditions that a differential equation must satisfy in order to be termed as a linear differential equation. If it fails to fulfill one condition, we say it is non-linear differential equation. Whether it's a first order nonlinear, second order nonlinear, or any other thing. So the first linear condition is the dependent variable and all its derivatives occur only in the first degree. So most at times our dependent variable, we write it as what? Y. We mostly use y as our dependent variable. So in this case, we are saying the dependent variable and all its derivative occur only in the first degree. So we can only have one. It means they must all be in the first power. They must all be in the first power, but they can be in any order, whether it is the first order, whether it is in the third order, whether it is in the second order. Okay, but when it becomes something like this, let's say I have this power 3, y prime power 3, this becomes, it will be in my, what do I say? It will be in my third degree. So I'm going to term that differential equation as non-linear. So at the end of this video, I'm going to do some examples to clarify some things. The next one is what we call there must be no product of the dependent variable and any of its derivatives. Let me say that again. There must be no product of the dependent variable and any of its derivatives. Okay. There must be no product of the dependent variable and any of its derivatives. So if I see something like y dy, given that y is my dependent variable, then this situation here makes my differential equation nonlinear. Or if I see something like y square in my differential equation, it suggests that it is nonlinear because I cannot have any product of my dependent variable or with its derivatives. Do you understand? And the next one, the last but not the least, is there must be no transcendental function of a dependent variable or its derivatives. So when we talk about transcendental functions, we are talking about our trig functions, our logarithm functions, our exponential functions. We cannot have a transcendental function of. So let me clarify something here. Let me use another color. Let me use yellow. Okay, so let's say I have sine x, y sine x over here. So given that y is my dependent variable, okay, so this right here still becomes a linear, makes this differential equation still linear because it is different from writing sine y. This one is sine y, sine of y is different from y times sine x. So we have to be very cautious about this. If I write y ln x, this doesn't make my differential equation nonlinear. Okay, But if I write len y, this makes my differential equation non-linear. Okay, so I'm going to practice some 4 examples with you guys. The first one is the square. Let me write my square well. The square y over the t square plus y square equal to cos t. So with this, we say that our dependent variable is our y, independent variable is our t. So let's see, is this, you can pause this and check whether it is a linear or non-linear differential equation. So with this, we can see that we have, let me use another color, we have this here, y square, and our first condition said what? Our dependent variable and all its derivative must be in the first degree, but y square is in what? The second degree. Okay, y square is in the second degree, so this makes our differential equation non-linear. Okay, let's go to another example. We have the square y over the t square plus yt equal to cos t. So let's see, our first condition is satisfied. They are all in the first degree. Let's see, the second says what? There must be no product of the dependent and its derivative. So here there is no product and its derivative. And thirdly, there is no transcendental function of the dependent variable. So this is linear. Let's look at the third one. The third one says the 4y over the x4 plus y cos s is equal to ex. So you can pause and check whether it's linear or non-linear. So with just a glance, I can say that this is what? A linear differential equation, because they are all in the first degree, and second, there is no product of the dependent and any derivative or itself, and lastly, there is no transcendental function of, remember this is cos x, so it is not cos of y, it's cos x. Even though it's multiplying the transcendental function, it is not a function of the transcendental function. Okay, and the last but not least, I have y dy dx plus x is equal to 2. So if you've been following for now, you know that this is non-linear. This is because we have a product of the dependent variable and its derivative. So therefore, this makes this equation non-linear. So that will be all for this lesson. You can let me know of any questions in the comment section. Thank you.